In CP3-6, you're going to learn how to calculate arc lengths. Before we get into this lesson, it's important to make sure that you remember and understand the difference between measure of an arc and length of an arc. So for example, if we have a circle like this, and we have this, and it's asking for the measure of this arc, that is the same thing as this angle. Okay, that arc is the measure of that angle. Now, if we're asked to find the length of that same arc, okay, you are going to consider the actual length of this. So if you were to put a tape measure around it, what would that tape measure say? It has nothing to do, or it's not related to, the central angle. Okay, the measure of an arc is in degrees. The length of the arc could be in inches, it could be in feet, lots of things, but it's not in degrees. What fraction of the circle is each arc? So this one's asking for length. It says if the diameter of each circle is 24 centimeters, what would be the length of each arc? So we're imagining if we're putting that tape measure over, what length do we have? As we consider this, we need to think about the circumference. The circumference of this is pi times diameter, so 24 pi. Now as this first one, if we're looking at it saying 180, that is 1/2 of our circle. So we want 1/2 times 24 pi, which is the same thing as 12 pi. So the length is 12 pi. Let's look at the next one. 90 degrees is the same as 1/4 of our circle. So 1/4 times 24 pi, that is equal to 6 pi. So the length here is the same as 6 pi. Our last one, 120, well, maybe you're like, what is 120? What part do we have? It's 120 out of 360 total degrees, which is the same thing as 1/3 times 24 pi, which is equal to 8 pi. Hopefully, you're seeing a pattern to find arc length. The arc length is the same thing as the fraction of the circle times the circumference. More formally, it's equal to the degrees out of 360, so theta, and call it x, but we'll call it more formally theta, times pi times d, because that's the circumference. Find the arc length of AB. So just remember that when it is saying just 2 letters, that means it's the shortest distance, unless it tells you maybe that there's another letter over here like C and it says ACB, then it would want you to go that way, or if it says to find the longer route, okay, or the longer distance. For now, it's just asking for arc length AB, and let's remember that we're going to take our angle measure out of 360, or get that fraction, times pi times diameter. So 60 out of 360 is the same thing as 1/6 of our circle times pi. The radius is 12. 12 times 2 gives us a diameter of 24. We can simplify this. 24 divided by 6 is 4. So we have 4 pi is that length. This one says to find the length of arc GF. So that's this one here. Again, we have our angle out of 360, pi times diameter. I can see in this circle, the diameter is going to be 16. We'll do 16 pi. Our angle is 134 out of 360. 134 out of 360, I can simplify that down to 67 out of 180 times 16 pi. So we're going to do 67 times 16 and divide it by 180, and we get about 5.96 pi for that length. Our next example, find the length of arc AC. So this one here, if the angle B is 55, so here we have 55, degrees, and OC is 10. So this length here is 10. And some of you might be like, great, I'm going to do 55 out of 360. And you'd be so close, but you have to remember that the inscribed angle, so that angle on the circle right here, is half as big as our central angle here. And I need my central angle to deal with the arc length. So we're going to do 55 times 2 to get 110. And that is the theta we're going to use for out of 360. 110 over 360. Our diameter is going to be 20 because 10 times 2. Now we can do some simplifying. We have 1136 times 20 pi. So 11 times 20 divided by 36. We get about 6.1 pi.